This section is about multiplying monomials, so there'll be a lot of exponents and new properties about exponents that we're going to use. First property we have is if b is a real number and n and m are positive integers, then b to the n times b to the m equals b to the n plus m. I wrote here, what that really is telling you is if you have like bases, bases meaning the numbers underneath, the big numbers on the bottom, you can add the exponents. Here's a couple of quick examples of how that works. We have x to the fourth times x cubed. That's going to equal x to the seventh, since 4 plus 3 equals 7. In the next one, a to the eighth times a to the seventh, we add the exponents. We get a to the 15th. Here's another property. If b is a real number and n and m are positive integers, then b to the n to the m equals b to the m times n. This is what I refer to as power to a power. In this case, the exponents are right next to each other. There's no other letter. When that happens, you can multiply the exponents. So here's an example where we have x to the fourth to the third. Since they're right next to each other, I'm going to multiply them. That's x to the 12th. In the next one, we have the same situation. The 5 and 6 are both exponents of a, so I'm going to go ahead and multiply them. A to the 30th. For the final property we're going to talk about is if a and b are real numbers and n is a positive integer, then a to the b, all raised to the n power, equals a to the n times b to the n. What that's telling you is that you can distribute the exponent. Let's look at a couple examples like this. This gets much more complex. This 4 that you see here is going to get distributed to all of the parts. The 2, the x squared, and the y cubed. So I'll have 2 to the 4th times x squared to the 4th times y cubed to the 4th. Now we're still not done. There's still things that need to be simplified. Because now I actually know what 2 to the 4th is. That's 16. And I have a power to a power. Property said for power to a power, we multiply the exponents. 2 times 4 is 8. Here's another power to a power. 3 times 4, which is 12. So the final answer is 16, x to the 8th, y to the 12th. The next problem is just like it. We have negative 3ab to the 5th, and it's being raised by this power. It needs distributed to each of the parts, to the negative 3, the a, and the b to the 5th. So negative 3 cubed times a cubed times b to the 5th cubed. This requires some more simplification. Negative 3 cubed is like saying negative 3 times negative 3 times negative 3, which is negative 27. For the b part, we have a power to a power, so those get multiplied. 5 times 3 is 15. So my final answer is negative 27, a cubed, b to the 15th. So look at some additional examples of types of work you'll have. Here I have a monomial times another monomial. The two big numbers, the normal ones, 3 and 5, are going to get multiplied just like normal. That'll be 15. The x cubed and the x to the 4th, I'm multiplying like bases. The rule says I add the exponents. So I'll have x to the 7th. In the next one, I have an exponent outside, so I'll have to distribute to both parts. 2 will be raised to the 4th, and so will x cubed. me simplify that. 2 to the 4th is 16. It's like 2 times 2 times 2 times 2. In this one, we have a power to a power, so I'm going to multiply the exponents. 3 times 4 is 12. So I have 16x to the 12th. The next example I'm going to do is sort of a preview into what we'll see in the next section. It's a monomial times a polynomial. To do this, we're going to distribute the 3x to all three parts. So again, this is kind of a preview into what we'll go to next. All right, I'm going to multiply the 3x times the 2x squared, the 3x times the 6x, and finally the 3x times 1. What we've really done is made 3 smaller problems. First of all, when you see just a plain x, remember that that's an exponent of 1. If you need to, go ahead and write it in. All right, let's start with the first one. 3 times 2 is 6. I have like bases, so I'll add the exponents. X cubed. Here's another 3 times 6. That's 18. And I have like bases, so I'll add the exponents. 1 plus 1 is 2. And finally, I have just a plain 3x. So again, a preview into where we're headed next. Ideally, when we do this in the next section, this middle step here that we've just done, we want to try to eliminate. The goal is to have this middle step as a mental math step. Now at this point, if you need it, then you want to write it down. But again, the goal is to try to eliminate that. Let's try it. I want to do some mental math work. Go ahead and push pause and try these two using some mental math, and let's see how you do. All right, let's see. For the first one, I have 3x times 2x, or 6x squared. For the second one, I have 3x times 3, or 9x. For some students, this is difficult, and if you weren't able to get the right answer, then I suggest actually writing it out at this point, like this. Let's see how you did on the next one. The next one would be negative 8x cubed plus 12x squared plus 4x. If you weren't able to get that one, let's look at the expanded version of it. If anything, the negatives probably gotcha. Right here turns into a plus, so does this area. We can change those negatives into positives if that helps. All right, we'll do more of these in the next section. For now, we need to go ahead and concentrate on those exponent properties. Multiplying like bases, power to a power, and distributing.